Hi, this is John Claman with IntelliFinishing. One of the questions I sometimes get asked by potential customers is, how much system do I need to handle the parts that I need to finish? And while there are a lot of ways to answer that question, I'm going to show you one way to do that right now on this whiteboard behind me. And let's say they come in different sizes, shapes, different substrates. And so there's a lot of variety in the types of products that you might need to finish. And maybe there's a whole laundry list of different products. And that can be quite time consuming to try to drill into and figure out. Well, here's maybe a shortcut for how you could figure this out. Now, with a traditional conveyorized finishing system, the usual way that you indicate what its capacity is in terms of feet per minute. Basically, how fast does it run? And most of the calculations about the size of equipment that is placed on that system have to do with how many feet per minute does that system run. A system could run as slow as a foot or two a minute. It could run relatively quickly at, say, 20 or 22 feet per minute, or even a little faster. Pretty wide range, but most chain systems only run approximately X feet per minute with a little bit of variance, and they don't change much for different types of products. And so that's why a system like IntelliFinishing can be very helpful, because you can put a wider variety of products on the system. So let me illustrate that. And what we're driving for here with this calculation is a carriers per hour. We're not so much interested in feet per minute because our carriers can travel at different speeds at different sections of the track. So what we want to know is, how many total carriers per hour does your system need to be capable of? Let's say that this customer has a lot of different parts, but they have a ton of small parts. And let's just take the dimensions of the largest small part they have and assume that all the small parts are that size, even though we know they're not, because this will help build in a little extra capacity as we go through this process. So let's start with small parts. How many small parts do we need to do? Let's make it a nice round figure of 1 million small parts per year. And these small parts at their largest, and they could be much smaller than this, let's say it's a half a foot in length, a half a foot in height, and a half a foot in width. So there we've defined our small parts. How about if we look at our medium parts? Let's say we have to do 440,000 of these medium parts. Our maximum length might be 4 feet. Maybe it's a foot for the height and half a foot for the width. All right, how about some large parts? Let's say these parts are 8 feet long. Let's skip the volume. Let's say for volume, let's go 10,000. 8 feet long, 3 feet high, and 1 foot wide at their maximum potential dimensions. And then we have some extra large ones. This is a pretty important group, because the system has to be able to accommodate both the extra larges and the small and everything in between. So on the extra large one, we don't do a lot of those, but we'll say 7,000 in this case. All of these figures are kind of made up, but they'll work for our purposes. Let's say that's 23 feet long. A relatively long product, could be up to 3 feet tall and another 3 feet wide. And again, this could be, the products are different combinations, not a single product, but sort of a combined product part window size. So that's what we need to be able to process. The total on all of these parts is 1,457,000 parts. All right. So what we're also looking for with this exercise is, how big does our part window need to be? Now, because we have parts up to 23 foot long, usually what we're going to do, unless it's a very unusual circumstance, is we're going to assume that the length of the carrier is going to be the max of that. So our max carrier length is 23 feet. Now here our max height is 3 foot, but I am looking at these big items and I'm wondering, if we went to a higher system part window, could we put 2 of these on the same bar? And I think so. So I'm going to just go ahead and say, let's make this 7 feet tall. And then let's go ahead and make the max width that we're going to allow as 3 feet tall. Okay. One way we can look at this is we can take the 23-foot length and multiply it by the height of 7 feet. And that gives us 161 square feet of linear product flowing through the system. You could look at it as a cube as well, and that's certainly important for maximizing your part density. But for this exercise, this is the figure we want to know. So we need to fit these parts on this 161 square foot. Okay, so now we'll go over here and we'll do an estimate for how many parts can we fit on each carrier. And the way we might do this is that we would take this figure, the square foot, the linear square foot, and divide it by the max length plus about half a foot, 0.5, for spacing around that part, times the max height plus another half a foot. Now, if the parts are really small, you can squeeze those parts together even further, maybe only have 3 inches apart. And with an IntelliFinishing system, you can generally squeeze your products closer together than with a traditional system, but this is kind of a traditional calculation that one might do. So in this case, if we do the math on this, where we take half a foot, add a foot to it, and so that's a foot, times half a foot, add a foot, that's a foot. So basically, divide that into 161 is 161. So I could theoretically get 161 parts of those small parts on this load, this carrier load. On the medium side, we do the same math. We end up with 23.9, or we could probably round that off to 24 if we really wanted to. On the large ones, we end up with 5.4. 5.4 parts on that. We could probably round that up to 6 if we wanted to. We won't do that here. And we already determined we're going to put 2 of these on a carrier. All right. So then what we do is we take this number of parts per year and we divide it by the parts per carrier. And in this case, we end up with, 6,211, 18,447, 1,848, and 3,500. In other words, 7,000 divided by 2, 3,500. Now we add all of those numbers together, and we're at 30,006 carriers per year. Now all I have to do is divide that by, let's say, 250 working days, and then divide that by, well, that number is 120 carriers a day. And let's say it's a 10-hour shift or whatever the number of shifts are, or number of hours of working that the system will be working or on in a day. Let's say it's just 10 hours. So let's say that ends up being 12 carriers per hour. So that's the basic calculation we're looking for, is how many carriers per hour can we do? And of course, it all kind of starts with this number here, which is how many parts do you want to get done? And that number should be aspirational. It should be, 5 years in the future or 7, 8 years in the future, something that you can expand to over time. And that will vary by company and their rate of growth and things like that. But that's the basic process that we might go through for a set of parts like these. And again, there's lots of other ways to determine this, but I hope you find that helpful. Thanks. Oh, by the way, one last thing. Do you have a question that you would like to ask us at IntelliFinishing? If so, respond to our email and send us back your question. We'll be glad to include it on one of our future FAQ videos. Thanks a lot. Hope you have great luck with your next finishing system. If you'd like a spreadsheet that basically has all the formulas already preset for the video I did on calculating carriers per hour, I'd be happy to send that to you. Just drop me an email at Claman, Claman, at IntelliFinishing.com and mention that you'd like to get that spreadsheet, and I'll get it right out to you. Also, I have a little bonus information on that spreadsheet that will be very helpful for calculating the type of series that would be appropriate for the weight of your products. So that'll be a little bit of extra information that you'll see on there that we can use to help you with that calculation. Thank you. Have a great day.